So right now, I'm on this road that'll take us to the next clue. It's gonna be quite a doozy here. We're gonna be aware of all of our surroundings. We're gonna be totally safe when we're driving our car, and we just can't do any of this. Whoa! Oh dear, oh dear. Well, let that be a lesson for you, Mr. Magoo.
Bugger. Hey, how you doing? Let's find our clue. Not here. Oh, there it is. Congratulations on solving your clue. Now, go back and solve for asymptotes. Asymptotes? So, before we solve, let's have a little introduction to asymptotes. So, any kind of graph could have either horizontal, vertical, or slant asymptotes. So for horizontal asymptotes, you need to take the limit as the function as x approaches positive and negative infinity. This is an example of a horizontal asymptote. For vertical, you need to find the restrictions of your function, plug in the limit for f of x as x approaches the restrictions from the right and the left sides. Here's an example of a vertical asymptote. Very nice. For slants, this is the tricky one. You take the limit of f of x minus mx plus b, which you solve by long division, as x approaches positive and negative infinity, and that all needs to equal 0 every time. Here's an example of a slant. So, let's go back to the HQ, solve for horizontal asymptotes. Hello there! So, we just figured out how to solve for asymptotes, so let's start now. We're going to start with our horizontal asymptotes. So for our horizontal asymptotes, we need to take the limit as the function approaches infinity and negative infinity. So let's start with infinity. We need to plug in infinity in for every x into our function. So therefore it equals and now infinity minus infinity is impossible to do. So that is a no-no. We must manipulate our function. So, the rule that we need to use here is dividing by the highest power of x. And in this case, the highest power of x is 3. So we will divide everything by x to the power of 3. So, a couple things can cancel here. This can equal 1, and this cancels, and this becomes a 2. So we're left with 1 over x to the power 3 over 1 minus 1 over x squared. So we've manipulated now. Let's retake our limit. 1 over infinity to the power 3 over 1 minus 1 over infinity squared. Recall that whenever you have a number over infinity, it's always 0. So therefore, it's 0 over 1 minus 0. That result will just give you 0 over 1. So that means it's just 0. For this next function, we need to plug it in for negative infinity this time. So we're going to keep it manipulated like here, but we're just going to take negative infinity. Negative infinity to the power of 3 over 1 minus 1 over negative infinity squared. That will give us the exact same thing as before. Therefore, it is 0. Now, that means that we are going to have a horizontal asymptote at y equals 0, because both functions from negative infinity to positive infinity equal the 0. That's our first answer. Hello there. I'm practicing my croc crawl. Okay, well, let's get started then. So for vertical asymptotes, recall the restrictions for our function. X cannot equal 0, 1, or negative 1. If you've forgotten how we got those restrictions, please click on this video. So, we're going to start at x cannot equal 0. So for a vertical asymptote, we need to plug in the limit as it approaches 0 from the right and 0 from the left. I'm going to write out all the steps and I'll explain it after. So, for this function here, we plug in 0.1, a number that's slightly bigger than 0. So 0.1 cubed minus 0.1 is always going to be a negative number. And this one is always going to be positive, therefore it is negative infinity, a positive number over a negative number. The limit as it approaches 0 from the left, I put in a number that's slightly smaller than 0, 0.999 cubed minus 0.999 is always going to be a positive over a negative, which is negative infinity. Therefore, we have a vertical asymptote at x equals 0. That's the first asymptote. Now we're going to solve for when x cannot equal 1. So, I am going to do the exact same thing as before. I'm going to write it all out and I'll explain it to you after. I plugged in a number that was slightly bigger than 1. So 1.001 to the power 3 minus 1.001 will always give you a positive number over a positive number, so you will have positive infinity. Now, as it approaches 1 from the left, I put in a number that's slightly smaller than 1, 0.999 to the power 3 minus 0.999 will give you a positive number over a negative number, which equals negative infinity. So therefore, you have a vertical asymptote at x equals 1. Now, we'll move on to the last one. So now we're going to solve when x cannot equal negative 1. So, same thing, I'm going to write it out and I'll explain later. I plugged in a number that's slightly bigger than negative 1, negative 0.999 to the power of 3 plus 0.999, because a negative minus a negative equals plus. Positive over a positive is infinity. So, a number slightly bigger than negative 1 is negative 0.001 to the power of 3 plus 1.001 is a positive over a negative, which gives you negative infinity. Therefore, you have a vertical asymptote at x equals negative 1. And those are all our vertical asymptotes for this graph. Let's continue on and move on to slant asymptotes. So now let's solve for our slant asymptotes. So, if we have a horizontal asymptote, do we have a slant asymptote? What do you think? What do you think, my friend?